Now we want to ask the question, what are the problems with using the old value of pi? As one individual said to me, who gives a crap whether you use 3.1416 or 3.1446, besides the fact that you want to use the correct value of pi. Brief review, we physically measured pi, which you've already seen, and we cut a 1 unit diameter circle and then measured the pi circumference. It of course came out to be 3.1446. Definitely not 3.1416, which is the old value of pi, and it's just an approximation. Number two, we took that value measured in our little laboratory here and mathematically proved by squaring each side of Kepler's golden ratio right triangle that pi always reduces to 4 divided by the square root of the golden ratio. Looks like a 0 with a line through it. That's phi. Phi is the golden ratio, and the square root of the golden ratio is what is represented here. Once again, who cares? Well, let's point out a couple of who should care. In A here, we note that in 2018, in November, I believe it's November 13th, there will be a symposium in Europe, a meeting for establishing standard weights and measures to redefine the standard kilogram. Okay, the current weight of the kilogram is using iridium and the 40 different iridium cylinders dispersed throughout the nations of the world through their half-lives and their different half-lives. The rate, they're all the same iridium, are all off. They don't match up. So the object is to redefine the standard kilogram using objective universal criteria, and that what they've come up with to do this, let's just say the project team, is to measure a silicon-28 isotope pure crystalline sphere. So the US and others in the project team have bought for $3.4 million each very purified Si-28 crystalline globs that they're polishing to spheres, about the size of a softball. And they're going to, knowing the density of this pure crystalline silicon-28 isotope to 99.999%, and the density, they can then, after they calculate the volume of a sphere, measure how many atoms make up that standard sphere. That way, you could drop the sphere and it could be destroyed, but anybody could still go back and recreate the standard kilogram weight. That's the whole idea behind it. So let's, moving fast forward here, the volume of a sphere is 4/3 pi r cubed. So the big question that I have is, what value of pi will the Si-28 Avogadro project team, that's the name of the team, use to calculate the volume of the sphere? Are they going to use old pi, 3.1416, which we know is wrong? Are they going to use the new pi? If you use the old pi, your sphere, and therefore your fear, is going to mislead you into thinking that you have X number of atoms in that sphere, when actually what you've measured is your value that you come up with is too short, and in reality you're going to have more atoms. You're going to be off. And I've gone through basic calculations, and you're going to be off by some 4.3 billion atoms. That's a little cube the size of 7.5 millimeters by 7.5 millimeters by 7.5 millimeters, and that's significant if you're going to establish a standard. The standard will be used for commerce and, of course, science. For every planet, yeah, every planet in the universe, but mostly for every country on planet Earth when they get through establishing what that value is. It will be the new Avogadro constant. What makes matters worse, if you use the old value of pi, is that the new value of the standard kilogram will also be used to redefine 3 more standards that they're going to come up with: the ampere, the mole, and the Kelvin. So if you have the wrong value of pi, and you calculate therefore the wrong volume of the sphere, whose diameter they know is 93.6 millimeters, and you come up with the wrong volume, and then you use the density of the silicon-28 isotope to project how many, or to determine exactly how many atoms are in that sphere, you're going to come up with the wrong answer. Then when you come up with the wrong answer for the standard kilogram, you will then, if you use that as a basis and do the ampere, mole, and Kelvin, zap, 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 you're going to have 3 more wrong answers. So what you're facing on who gives a crap is these guys should give a crap. Mainly the Commerce Department in the U.S. should give a crap, because they are responsible for overseeing the United States National Institute of Standards and Technology, and those project team is working out of there. I go into more about this on the website, measuring pi, squaring phi. So what's the second problem? And here's another problem. The NIST website, the National Institute for Standards and Technology, for all our standards and measures that scientists use. For example, they show, and you can find it on their website, Planck's constant. And you can also find Planck's h-bar constant. Planck's constant is represented by h. Physicists, for some reason, I haven't delved into why, like to use h, Planck's constant, divided by 2 pi. They call that the Planck's h-bar constant, or the short h. And once again, if you use the old value of pi, your h-bar constant for Planck's constant will be wrong. Planck's constant is not the only constant that's used by physicists. They log on to the NIST website and you'll see a whole bunch of them. And like I said, physicists like to divide by 2 pi for whatever reason. Maybe they're questioning Planck's constant itself and other constants, and for some reason dividing by 2 pi helps them come closer to whatever they're looking for, or else it keeps popping up and they're wondering why. The point is, they too should give a crap. So the 2018 symposium in Europe should give a crap, NIST should give a crap. You want some more? NASA should give a crap. They're going to launch spacecraft to Mars and further, and so you're going to be concerned about elliptical and also circular orbits to probably slingshot your vessel to get closer to your target. And if you're off by 0.003, that matters when you're traveling light years. So if you're doing genome research and you're doing micro measurements, you will want to use the correct value of pi. So there are many reasons besides just a grammar school teacher teaching kids the area of a circle